Okay, so we are going to continue with scatter plots today, and I will show you in a little bit how you can make a scatter plot on the calculator, and then also how you can calculate this numerical measure called correlation, which helps us assess the strength of a linear relationship. Okay, so we do want to come up with a numerical measure to measure the strength because it is really difficult for us to just look at a graph and tell how strong that relationship is. So there are some things that can kind of be deceiving, or if you have a lot of points or not a lot of points, it makes it difficult to tell. So we are looking at correlation, and you need to know that the variable we use for correlation is R, and it measures the strength of linear relationships. And it is important that we're only using correlation to describe the strength of linear relationships and not curved relationships. So a few facts about correlation: it's always going to be between positive and -1, and that's inclusive. If correlation is positive, then it tells us we have a positive association. If it's negative, we have a negative association. And then correlation values that are close to 0 indicate that we have a weak linear relationship. And then as we get closer to plus or minus 1, those values of correlation indicate stronger linear relationships. In the rare case that your correlation is exactly 1 or exactly -1, that means you have a perfectly linear relationship. So here are some examples of graphs, and you can just kind of see a correlation value of 0 here in the top left. Those points are fairly scattered all over the place. That would be a very weak linear relationship. Here in the top middle, they're starting to come a little closer together. Definitely a negative trend here, a decreasing trend, but still pretty weak, so -0.3. Top right here, definitely an increasing trend, so it's going to be a positive correlation, but still fairly weak. And then we're getting closer to a straight line, negative down here, positive, and then negative again, but just getting closer and closer to those plus or minus 1 values. So the formula for correlation is pretty complicated. You're going to see it here. This is not something that you are ever going to have to do by hand. So you can see that really what the correlation is doing is it's relating the x value to its mean and variability with standard deviation. And then it's doing the same with the y. So it's taking the y value relative to its mean and standard deviation. And it does that for every entry in the data set. And then it's basically finding an average of how closely associated those values are to their means, and again, relative to their standard deviation. So this formula here for correlation, it is in that formula packet that you're allowed to use on the AP exam. I have never seen a scenario where they've asked students to calculate correlation by hand. But it's one of those things that, just like standard deviation, it's there. So technically they could ask you to do it, but it's just not likely. So some facts about correlation. If you switch your explanatory and response variables, correlation will not change. It's going to remain exactly the same. And if we change units, it is not going to change the value of correlation. Those points are going to be just as closely associated as they were prior to the change. And then correlation does not have a unit of measurement itself. So when we report correlation, it's just R equals a number. That's it. No units attached. It is a requirement that both variables are quantitative. We need an x and a y variable. It is not appropriate to use correlation with curved relationships. Like I said, we use linear relationships only. And then correlation is non-resistant. So when we're talking about outliers, they can really impact the value for correlation. So because of that, it's not a complete summary of two variable data. Like, say I had this scatter plot here and all of my points were really closely associated and I have a really strong correlation, but I have one outlier here. This one outlier is going to take my correlation from being really close to +1 to closer to 0. It's going to pull it down towards that outlying point. And so if we just reported the correlation here, it doesn't give us a clear picture that most of our observations fall very close to that line. We just have an outlier that's impacting that numerical measure. So here are some examples of estimating the correlation. And I actually have an app that I'm going to post for you guys that you can test practicing guessing correlation, just to kind of see how difficult it is. But this one here definitely has a positive correlation, probably fairly close to, I would say maybe 0.9, maybe 0.85. They're pretty close to a positive linear relationship. This next one here is a bit weaker, and so in this case, it's still positive, but maybe closer to maybe positive 0.6 or so. Here you've got points that are kind of spread all over the place. This one's going to be closer to 0. And then again, this one's fairly well spread out. This one's negative, but it's still fairly weak, so maybe somewhere around like negative 0.2. Okay, so here's your summary of section 3.1, and then I'm going to switch to the calculator to show you how you can make a scatter plot and find correlation there. So know that the scatter plot is an appropriate graphical display for two quantitative variables. You need to distinguish between the explanatory and response variables. Remember, explanatory always goes on X and response always goes on Y. When you examine a scatter plot, remember there are 4 things that you need to describe. Describe them in sentences and in context, just like you did in chapter 1. So again, it's direction, unusual observations, form, and strength, or DUFs if you need an acronym. And then correlation, we need to know that the variable R is what we're going to be using for our symbol. We need to be able to find correlation using technology and then know those facts about correlation. So it's between positive and negative 1, and the closer to plus or minus 1, the stronger the linear relationship is. Those facts about switching X and Y doesn't make a distinction between changing correlation, all of those things that we saw today. All right, so here's your homework assignment for tonight. Oops, and then I'm going to go ahead and switch to the calculator here. Okay, so we are going to go ahead and look at the example from yesterday where it was the body weight and backpack weight. And so we need to enter this data into the calculator. So you'll just go to Stat Edit and enter all of the backpack weights into list 1 and all of the body weights into, I'm sorry, I said that backwards. All of the body weights into list 1 and all of the backpack weights into list 2. So I'm going to go ahead and make this right side up here for you. And make it so you can see both of these at once. Make this a little bigger. There we go. Okay, so to enter your data, you'll go ahead again and hit Stat and then Enter for that Stat Edit menu. And then I already have everything typed in here, but we're going to type all of the body weights into list 1, all of the backpack weights into list 2. And if you need to pause the video to do that, you can go ahead and do so. I do want to mention that you need to make sure that you don't break the tie between the X and the Y variables. So like my 131-pound person here has to be paired with their 29-pound backpack. So for whatever reason, when you're typing in data, if you realize you missed an entry, you have to go back in and put it in the right spot. You can't just tack it on the end of the list. Okay, so once the data is in your calculator, you can make your scatter plot. You can do so by hitting second y equals, so same menu that we make all of our graphs in. Again, just watch and see. If you've got a bunch of plots on, you're going to want to change that so that you're not trying to make multiple graphs at a time. I only have plot 1 on, which is the plot that I'm going to work with, so that's okay. I'll hit enter. I want to make sure that it's turned on. And then for my type, this first one here is the scatter plot. And then when I select it, it changes my input because I need to tell my calculator about an X and a Y list. So my X list is L1, my Y list is L2. Again, to get the L2 or to get another list, if you needed, say, L3, it would be second and then the number 3. Those list options are above the number keys. And then the mark is just how you want your points to appear. So you can just pick whichever you're most comfortable with looking at. I think the dot is pretty small, but that's, again, just a matter of personal preference. Once you have this screen set up, you can go ahead and hit zoom. Again, if these tabs show up on the bottom of your screen, you can hit second and then mode to quit out. So it's Zoom 9 for Zoom Stat, and that's going to show you your scatter plot. One thing to keep in mind is if you're getting an error here, there are a couple of reasons that could happen. In your y equals, maybe you have an algebraic equation that needs to be cleared out. Or in your stat plot, maybe you've got multiple plots on. The other place to double check now that we're doing scatter plots is your original data. If I go back into my lists, and if these lists are not the same length, then I'm trying to plot an x value with no y or a y with no x, and that's going to create a problem. So those are kind of the three places you should look for any issues when you're graphing. Okay, so I have my scatter plot here. If I wanted to find the ordered pair for a particular value, I can hit my trace key, and then it's going to put my cursor on the point and give me the x and y coordinates. And then I can just scroll over to the right to the next point and continue to get those values. It does look like my cursor is kind of bouncing all around randomly. It's actually just going in the order that the points were entered into the calculator. So it's just going to the 120 with the 26 first, and the 187 with the 30, and so on. So that's your scatter plot. We also can calculate correlation on the calculator. And so you're going to do that under your stat button. So it's stat, scroll over to calc, and then it's the linreg option that you're working with. There are two linreg options in your calculator. There's option 4 and option 8. It does not matter which you use. Option 8 is more in line with what your textbook shows you, but they're both going to give you equivalent values for correlation. And then when we end up doing other things with linreg, the other numbers will be the same as well. So either option 4 or option 8. And then you have to tell your calculator your X list and your Y list. So I've got L1, L2. I'm going to leave frequency list blank. I'm going to leave store regression equation blank. And then I'm going to go down to calculate. If you don't have this menu that shows up on your screen, if it just says linreg AX plus B with your cursor next to it, then you're going to type in L1, comma, L2, and then hit enter. When you do that, you might see what I'm seeing here, or you might see an R and an R squared showing up below. We do want to see that R and R squared. R is our correlation. If you're not seeing an R and R squared like I am here, you need to turn your stat diagnostics on. And that's something that you're probably only going to have to do once unless you reset your memory or your batteries totally die. And depending on the software on your calculator, it's going to be in one of two places. So one way that you might find your stat diagnostics is by hitting the mode button, and then you can scroll down. And I have here stat diagnostics, and it says off and then on. I'm going to select on and hit enter. And then I can get out of this screen by hitting second and then mode. If you went to that mode screen and you did not see stat diagnostics, there's another way you can get to it. You can get to it from your catalog. You're going to hit second and then 0 for catalog. And then you need to scroll all the way down to diagnostics on. You can get there a little quicker because your alpha key is on here. So I can hit my D and then scroll to diagnostics on. Again, it's diagnostics on that you want. So I'll hit enter and then enter one more time. Now that the diagnostics are on, if I go back in and hit stat, calc, linreg, tell my calculator my list, everything else gets left blank for now, and calculate, I get my correlation. So my correlation, or R value here, is the 0.7947. When you report correlation, I would say 4 decimal places is appropriate. You can keep more, but you certainly don't need to write down the entire correlation that your calculator gives you. If you don't have access to a calculator, you can also find correlation on Statlet. So I'm going to show you that real quick here. You have 2 quantitative variables. So on your Statlet screen, you would click on 2 quantitative variables. And then you just type the observations in for the explanatory and response, and then you would hit begin analysis. Okay, so I typed all the data in here with the body weights and backpack weights. And then once I do that, I can just hit begin analysis. I get my scatter plot and it labels it nicely for me if I type in those variable names up here. And then if I scroll down, I have an option to calculate correlation. So I would hit calculate correlation and then it gives me that R value of 0.795.